Hello, good afternoon students. Welcome back to chemistry online classes. See students, in the last class we have discussed that we have started 17 group elements. Okay, I told you these 17 group elements are called halogens. Halogens are nothing but salt forming elements. Okay, salt forming elements. These halogens include fluorine, chlorine, bromine, iodine and astatine. Astatine is a radioactive noble gas. Okay, radioactive halogen. Now, general electronic configuration is Ns2n3 and these are the most electronegative elements in the whole periodic table. Electron gain enthalpy of chlorine is greater than fluorine. Why? Due to smaller atomic size of fluorine as it experiences repulsion from incoming electron, which is very important point to be noted. Okay, then I told you regarding regarding oxidation state. Oxidation state exhibited by these halogens -1 to maximum +7. Okay, -1 on and +7 in first, second and third excited state. Then I discuss with you reactivity with the hydrogen finally, and along with that additionally bond dissociation energy and oxidizing property of halogens in detail. Okay, right. Now in continuation today, another chemical properties as I told you yesterday, reactivity with oxygen. Okay. See, first point to be noted, this fluorine reacts with oxygen and forms OF2, oxygen dichloride, and O2F2, dioxygen dichloride. Both are powerful oxidizing agents and as well as they are fluorinating agents. They are used as fluorinating agents. And especially this O2F2 it is used to prepare plutonium hexafluoride and liberates oxygen. Okay? And liberates the oxygen. And this is used in enriching plutonium from the spent nuclear waste. Okay, this is one. And both oxygen dichloride and dioxygen dichloride, they are highly electronegative. More heat energy is liberated because the first most electronegative element is fluorine followed by oxygen. That's why both are highly electronegative. Explosive reaction takes place. That's why they are used in nuclear reactors to enrich plutonium from the spent nuclear waste. Right? And both powerful oxidizing agent and fluorinating agents. Next is this chlorine, bromine, iodine. All generally oxides of chlorine. Oxides of chlorine are stable than oxides of chlorine are stable than oxides of bromine. Oxides of bromine are stable than oxides of iodine. Okay, that means Cl2O5 stable than Br2O5, right? Br2O5 and even I2O5. Got it? Even higher oxidation state, the oxides are more stable or more coherent than this particular lower oxidation state, and they are not stable. Generally, apart from this chlorine also, Cl2 exists as Cl2O6, right? Cl2O4, then Cl2, then Cl2. Here +6 oxidation state, here +4, here also +4, right? And here +2. Like this, they are stable. Not only this, and all these are acting as what? Oxidizing agents. Powerful oxidizing agents. Okay, and also this Cl2O used as disinfectant. Disinfectant where in purification of drinking water. Okay, right. And apart from this, when we come to bromine, bromine also exists as Br2O, right? Br2 and Br3. This is that got low temperature, because they are existing as liquids and they are also powerful oxidizing agents. And lastly, finally, iodine also, I2O4, I2O5, okay, sorry, I2O3, I2O5, I2O4, I2O5, they exist as solids. Okay, and these are also oxidizing agents, acts as powerful oxidizing agents. That means from this example, what you come to know, all halogens, fluorine, except fluorine, bromine and iodine form their monoxides, dioxides, trioxide, pentoxide, even heptoxide also up to +7. Okay, so this will be Cl2O6, even Cl2O7 +7 oxidation state for fluorine especially, right? So this is all. That means oxides of fluorine are more stable than oxides of bromine. Oxides of bromine are more stable than oxides of iodine. And fluorine already you know that they are stable with this particular, not stable, but they are highly reactive because of their electronegativity, and they are used in enrichment of plutonium from the spent nuclear waste, and especially they are used as powerful fluorinating agents. Okay, apart from oxidizing agents. This is that means remember, as the oxidation state increases, okay, their acidic nature increases. All these are acidic. Why? Because they are non-metals: fluorine, bromine, iodine, except acetate. Okay, all are acidic in nature. +7 oxidation state are more acidic than +5. +5 they are more acidic than +3. +3 they are more acidic than +1. Okay, that's about reactivity with the oxygen. Now students, coming to reactivity with the halogens. How they react with the halogens? See, with hydrogen, I told you they form their hydrides. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. Right? With oxygen, they form the respective, that's only monoxides, dioxides, trioxides, pentoxide, heptoxides. Higher oxidation state are more covalent, more acidic, and even more stable than lower oxidation state element. But finally, chlorides are more stable than bromides, bromides are more stable than iodides. Okay? Now coming to reactivity with halogens. Very strange. You are studying halogen and you are reacting with the another same halogen itself. So this is also possible only when there is a reaction between one halogen atom with a lower atomic size and another halogen atom with a higher atomic size. And try to remember this difference in electronegativity make them possible to form a compounds called as interhalogen compounds. Compounds called as what? Interhalogen compounds. Okay. See, that means chlorine forms chlorine monochloride, chlorine trichloride. Okay. And bromine forms BRF3, BRF5. Iodine can form IF3, IF. These are called interhalogen compounds. That means they are represented by general formula XX3 XX5 and XX7. And these are called as what? Interhalogen compounds. That means one halogen reacts with another halogen due to difference in electronegativity that makes the reaction possible. And these class are called interhalogens. Remember, see, chlorine higher atomic size, with a lower atomic size and more electronegative, small atomic size. High electronegative, large atomic size. That means X, larger size atom with a lower electronegativity. X dash, smaller size with a higher electronegativity. Got it? X, larger size halogen with a lower electronegativity. X dash, smaller size halogen with a higher electronegativity. See, bromine, larger size, fluorine, smaller. Like this, it is possible to form. It is represented by general formula XX dash, X3 dash, XX5 and XX7 plus 3 plus 5 plus 7 and plus 1. That's why I told you. Minus 1 in their hydride forms. That's it. Like this, they react with halogen and form class of organic compound called as interhalogen compounds. Got it? So this completes reactivity with the halogen. See, that means reactivity with the oxygen, reactivity with the hydrogen, reactivity with the halogens and oxygen property, bond dissociation energy, 2 more additional points already discussed, right? Now what is remaining as usual? Anomalous properties. Anomalous property. Before anomalous property, even the reactive metals. These halogens react with the metal. For example, magnesium chloride, MgF2. Okay, MgF2Mg. MgF2, magnesium chloride. Aluminum chloride, magnesium iodide. Like this, if the size of the anion increases, covalent character increases according to Fuzzen's rule. That means if you take MgI2 is more covalent than MgF2. Why? Because the size of anion, as size of anion increases, covalent character increases. That means magnesium iodide is more covalent than magnesium fluoride. Magnesium fluoride is more ionic. Smaller size, more ionic. Larger size, less ionic. More covalent character increases as the size of halogen increases. That's only halogen character follows F, Cl, Br and I. More ionic, more covalent. What is therefore HI is more covalent than HBr. HBr is more covalent than HCl. HCl is more covalent than HF. HF is more ionic than HCl. HCl is more ionic than HBr. HBr is more ionic than HI. Remember, ion more covalent, fluorine less covalent, more ionic. Like this is according to Fuzzen's rule, what you studied, where in the chemical bonding. That means they react with the respective metal from the respective halides. But the size of halogen increases, covalent character increases. That's it. So students, now coming to next anomalous properties. Anomalous properties of fluorine. See, I told you the 15 group, it is a nitrogen. 16 group, oxygen. Now it's a turn of 17 group, fluorine. 18 group, they are all stable. Nothing there, the question doesn't arise. Okay, what are the properties? First, in terms of oxidation state. Oxidation state. Okay. See, fluorine exhibit -1 at the most +1. That means oxoacid. That is -1 +1 in HF4, oxoacid of the fluorine. But rest other elements, they exhibit -1, +1, +3, +5, +7 oxidation state. This is the difference. Second case regarding reactivity. Fluorine is most reactive. Because of high electronegativity and low bond dissociation energy. But what about other elements? Other elements are less reactive compared to fluorine. Okay. Coming to the next students, that is bond dissociation energy. That's one. Bond dissociation energy. Bond dissociation energy. Bond dissociation energy of fluorine. Fluorine is having less bond dissociation energy. That's why I did it. Okay. Other elements have more PDE, bond dissociation enthalpy of energy. Right? Okay. Then hydrogen bond formation. Hydrogen bond formation. Okay, fluorine can form hydrogen bond easy, more easy. Others cannot. See, there are four main points through which we can differentiate fluorine easily from other elements. Then apart from this, in electronegativity, okay, electronegativity, and also I told you electrode potential, that is E0, okay, and even reactivity is high. Reactivity is high for what? Fluorine. But other elements, less electronegative, less electrode potential, less reactivity. But electron gain enthalpy, bond dissociation energy, right? They are less for this fluorine. But other elements they are having more. And also oxo acid formation. This is very important. Fluorine can form only one oxo acid. That is HFO, hydrofluorous acid, plus one oxidation state. But other elements not like that. They can exhibit chlorous acid, ClO. Okay, hypochlorous, chlorous, chloric, and perchloric. And repeat, HClO, hypochlorous, chlorous, chloric, okay, then perchloric, +1, +3, +1, +7. Even it is exhibited by bromine also and iodine. To some extent, exceptionally, sometimes they will not form this type, but they exhibit. But fluorine only one. Okay, due to low bond dissociation energy. And lastly, fluorine is having only 2 electrons in the penultimate shell. Fluorine is having only 2 electrons in penultimate shell. Means fluorine, what is the atomic 1s2, 2s2, 2p5. Penultimate shell means last but one. See, this is for octet, no? See, last but one. In between, this is duplet. So this is another 2 electrons. 2 electrons in penultimate shell. But other elements, chlorine, bromine, iodine, they are having 8 electrons. So how, sir? Once again I am repeating. Fluorine is having 2 electrons in the penultimate shell. Penultimate means last but one. When we write outer electronic configuration, they are having 7 electrons. P orbital, last but one is this one, 2s. Like this for chlorine. Fluorine, what will write for fluorine 17, right? 1s2, 2s2, 2p6, right? 3s2, 3p5. For this thing, these are octet, right? And this is once again duplet. Last but one means, if you take this one, last but one in between here in between what? For this. Okay. You have to remove this and remove this. Last but one penultimate shell. 6 plus 2, 8 electrons. Other elements, chlorine, bromine, iodine, they are having 8 electrons in their penultimate shell, but fluorine only 2 electrons. Because why? D orbitals absent. Covalency is only 2 or maximum 4. But other elements, covalency 5 or 6. I told already what is covalency. Number of covalent bond formed by the element is called covalency. What is valency? Is the combining capacity. Totally both are different. So don't confuse. Okay. This is how we can differentiate fluorine from rest of the element. But this point is not necessary. Just you can write 4 points. Just remember easily. Oxidation state, reactivity, bond dissociation energy, and formation of hydrogen bond, and oxo acid. 5 points more than enough. Okay. Right. So why it differs? Once again, why it differs? Reason for anomalous property. I already told you reason for anomalous property. Reason for anomalous property remains. Reason for anomalous property. Reason for anomalous property of F2. That is number 1. Smaller atomic size. Same. Smaller atomic size. Okay. Then second, higher electronegativity. Third, low bond dissociation energy. Low bond dissociation energy. And absence of d orbitals. These are the reasons for anomalous property. See in the nitrogen, okay, even oxygen, and here fluorine also remains plus. Smaller atomic size, higher electronegativity, high ionization energy, definitely. But here low bond dissociation energy adds here, and absence of d orbitals. Even you can also write fifth one. What? High ionization energy. Because of this, it is differentiating from rest of the elements. So this completes even what anomalous property of fluorine. How it differs from rest of the elements, including all in detail physical properties, addition of 2 more properties other than 15 and 16. What are those? Bond dissociation energy and oxidizing power. See, extra, right? That's what. That means this completes all the anomalous. 1 2 marks question is compulsory in theory. What's that? Anomalous properties of either nitrogen, oxygen, or fluorine for 3 marks. Or else reason for anomalous property. Pakka question for 2 marks. Okay. Alright. So this is about generally what the characteristics, physical properties. Okay, general traits, chemical reactivity, chemical properties, right? And even lastly, anomalous property and reason for anomalous properties of, in detail, halogens, 17 group elements. Okay. Now we shall go for next one, compounds of 17 group. Compounds of 17 group. So after completing physical properties, chemical properties, and anomalous properties of fluorine, physical properties, chemical properties of halogens, and anomalous properties of the fluorine, how it differs from rest of the elements. Next, compound of the 17 group as usual. As we have discussed in 15 group dinitrogen, okay. Then later nitric acid and ammonia. The same way, 16 group dioxygen, ozone, sulfur dioxide and sulfuric acid by contact process. And 15 group we also studied phosphorus, color drops, white phosphorus, red phosphorus, black phosphorus, compounds of the phosphorus, right? Phosphine, phosphorus trichloride, phosphorus pentachloride and oxidation of the phosphorus. The same way, 16 group also contact process, sulfuric acid, sulfur dioxide, next then ozone, dioxygen, right? And oxidations of the sulfurous we are studying. Same way here also we will study chlorine, HCl, then interhalogen compounds, and lastly oxidations of the chlorine. Okay, that completes this 17th group. So today we will try to complete another one important compound of the 17th group, that is chlorine. So you know that chlorine is a highly pungent odor, that is gas, colorless gas having pungent odor in the lab generally, highly suffocating. Pungent odor. See the laboratory in non-qualitative analysis, you will test for chloride radical. Chloride radical. How? Just take a salt, a dry test tube in a salt, add concentrated sulfuric acid. If colorless gas having pungent odor, giving dense white fumes with a glass rod dipped in ammonia, that indicates chloride radical. Okay, and you confirm it by silver nitrate test. Take salt solution, add 1 or 2 drops of silver nitrate solution. If we get white curdy PPT of silver chloride easily soluble in ammonia, okay, then it's a chloride is confirmed. That is called silver nitrate test. Now this actually chlorine is a diatomic molecule. It was first discovered by the scientist Scheele in 1774. Okay, that is Scheele. Yes, this is and in 1810 its chemical nature was noticed. Chemical nature was noticed by, that is named and noticed by Davy, the scientist Davy, D.A. Davy. Okay, then how this chlorine is prepared in the laboratory? Preparation part. Laboratory preparation, lab preparation. Laboratory method of preparation. See, in the laboratory, chlorine is prepared by just reacting, pouring that is concentrated hydrochloric acid on the crystals of potassium permanganate. When potassium permanganate reacts with a concentrated HCl, it gives highly irritating pungent odor gas, that is chlorine gas. Okay, see here. What is the reaction behind it? Potassium permanganate with HCl. First we read, that means what are the products, right? Expected products. Potassium permanganate reacts with HCl to form KCl, right? Itself will be reduced to minus sulfate MnCl2 plus, that is your water, and then our main target product chlorine gas. Okay. Right. Now you see 4 chlorine atoms. So normally, how to balance it? Now see here. Starting with the potassium or else chlorine. Chlorine 2 plus 2, 4 are there. So first in the heat and dry method, let us we will multiply here by 2. So 2 4 the 8, 2 KCl, 2 MnCl2, 2 manganese, 2 potassium. Okay. Now 2 4 the 8 oxygen atom, therefore 8 H2O. Right? 8 H2O. Therefore now hydrogen becomes how much? 16. So here 16 HCl. Got it? Then what is remaining? Chlorine. 2 chlorine here, 2 is 4, 4 plus 2 6. How many total? 16 are there, therefore 5 Cl2. Overhead now. This is how chlorine is prepared in the laboratory by reaction of concentrated hydrochloric acid on potassium permanganate crystals. Potassium permanganate crystal get reduced to +7 to manganese chloride. Okay, and this one minus 1 get oxidized to 0. It's a case of oxidation and reduction reaction. It's a redox reaction. Okay? Right. So that's about laboratory method of preparation, lab method of preparation. Not only lab method of preparation, apart from this, you can also prepare chlorine by using oxidation of manganese dioxide, pyrolusite 4 with HCl, hydrochloric acid. Here are the same thing. Chlorine gas will come out, okay, and H2O. No more any other products. Very simple, right? So 4HCl, 2Cl2, 2H. Over and out. And what about Mn? This will be, MnCl. MnCl2, 2H2O and MnCl, 4HCl. Now it's a completely balanced equation, no doubt. Balanced equation. Not only this, even third, if you take MnO2 with, instead of this HCl, if you use mineral acid, sulfuric acid, you need a sodium chloride, because our main aim is to get chlorine. The salt you have to get here directly by oxidation. Okay, that means here this will get converted into once again MnCl2 plus here sodium bisulfate NaHSO4, okay, along with water and chlorine gas, right? Okay, this is how we can get this one. 2 NaHSO4, 2 NaCl, right? Then chlorine, 4 NaCl, 4 NaHSO4. Then generally MnCl2 chlorine no balance, right? What about hydrogen? 2 oxygen, 4 4 the 16 16. Here only to make oxygen balance, what you have to do? That's important. So 2 H2SO4, 2 for the 8, and then 2 MnCl2, 2 MnO2, 4, 8, 12. Now this equation is not balancing. Now let us balance it. Sorry, 4 NaCl with 4 H2SO4, because sulfur is 4 here. No? 4 for the 16, 16 plus 2, 20. Now make it here balance here, 2 H2. I think now it's completely balanced. Right, now it's a balance. And then 2 plus 4 NaCl plus 4 H2SO4 gives 2 MnCl2, 4 NaHSO4, 2 H2O plus Cl. Here also same thing. Plus 4 to plus 2, reduce, and once again minus 1 to 0. And this is the byproduct. This is how you can prepare by another oxidation of MnO2 with HCl or mineral acid, sulfuric acid. If you use sulfuric acid, you need a salt, extra salt, because our main target is chlorine. Where if you directly react this, you won't get chlorine. Chlorine source is sodium chloride. Okay. Right. But in the laboratory, this is most important for chlorine. And these are for CET, just right. Okay. This is the laboratory method of preparation of what? Chlorine. Apart from this, another commercial method for there, it is there for chlorine. What is that commercial method? Commercial method is as follows. Commercial method is as follows. What is that? Beacon's process. Beacon's process. Industrial method. Industrial process. Industrial method. In the large scale, chlorine is prepared by oxidation of HCl with O2, and you are studied by at 17 to 23 Kelvin temperature using copper chloride as a catalyst. It will form Cl2 and H2O. So 4 HCl, 2 H2O, 2 Cl. This is how we can get that. So this is called Deacon's process. That in the large scale, chlorine is produced by oxidation of the hydrogen chloride with oxygen, heating to about 723 Kelvin temperature in the presence of copper chloride catalyst. Very, very important. VEIMP for 2 marks theory as well as for CET purpose. Okay? Right. And lastly, by electrolysis. By electrolysis of brine solution. By electrolysis of brine solution. What is this brine solution? I already know. It is called as 10% saturated aqueous solution of sodium chloride. It is called brine solution. Right? Okay, so generally see sodium chloride brine solution on electrolysis gives Na plus aqueous, Cl minus aqueous. On electrolysis, molten. This is molten because it is 10% aqueous solution. Even water also, aqueous also get dissociated to form H plus aqueous, OH minus. Now from your electrochemistry knowledge you know out of sodium, potassium, sodium will not discharge potential in this, hydrogen gets liberated. Okay? H plus aqueous gaining 2 electrons get reduced to hydrogen gas. This will remain in the solution. And here chlorine more discharge potential for chlorine is more. Out of these two, chlorine gets lost, that is E. Like this, chlorine and chlorine, they combine to form chlorine gas. Okay, this is that cathode, and this is that anode. That means at anode, chlorine is liberated and hydrogen gas is liberated at cathode, chlorine gas at anode. Okay. That means one of the byproduct chlorine gets liberated at anode during the electrolysis of the brine solution. Then so whatever remaining is Na plus and OH minus. Later they also trickles down, combines with themselves to form caustic soda, sodium hydroxide, and this method is called Nelson cell method. Nelson cell method of preparation of sodium hydroxide, caustic soda, which was studied in S block elements. Right? Here chlorine is liberated where? At the anode by the electrolysis of the brine solution. It is also important for CET purpose. Okay? Right. So this is how we can just go for this chlorine, various methods, but only one method is important. There are purely for CET purpose, what I discussed afterwards. Okay? Right. Now students, without wasting the time, let us come to physical properties. What are the physical properties of chlorine? See, chlorine is a pungent odor. Okay, pungent odor, greenish yellow gas actually. When saturated with the water, that means when you take potassium permanganate crystals in a conical flask, Buckner conical flask, and attach pipe to that, then add from the funnel concentrated HCl. The gas, pungent colored gas, will comes outside. When you saturate it with the water, that water will become greenish yellow. That's why it is greenish yellow in color, due to absorption and emission of light by the electron. Remember. Okay? Right. Now, this is highly pungent in odor, highly reactive, highly soluble in the water. Okay. Then what are the properties? This reaction with metals and non-metals. Reaction with metals and non-metals. How it reacts with metals and non-metals? Simple. See, it reacts with metals and non-metals and generally form their respective chlorides. For example, aluminium. Aluminium is a metal. Okay. Even phosphorus, calcium. Okay, even it reacts with the calcium. Not only calcium, even iron. Yeah. Okay, that's like this. Aluminium, phosphorus, even sodium. These are some examples. See, here it forms aluminium chloride, AlCl3. Here it forms PCl3 or PCl5 also, right? Or PCl5. Here, generally it will form S8 thionyl chloride, will form S2Cl, disulfur dichloride. Here it will form calcium chloride, CaCl. No. Here it will form ferrous chloride or ferric chloride. Okay, and here it will form sodium chloride. Okay, the balance equation 2Al, 3Cl2, 2AlCl3. P4, 4PCl3, right? 6Cl. Or P4 plus 10Cl. We'll get 4PCl. Got it? Thionyl chloride 4H2Cl. Therefore 4Cl. Over and down. Calcium chloride balance, ferrous chloride also balance, ferric chloride, we just 2Fe, 3Cl will get 2FeCl. And sodium chloride 2Na, 2NaCl. Like this is also important. That means chlorine reacts with metals and non-metals from the respective halide, that is chlorides. Right. Now, very importantly, now let us move to important chemical properties. Reaction with the ammonia. Reaction with ammonia and reaction with the excess chlorine. What will happen? Not only that, sorry, before that reaction with hydrogen. Reaction with the hydrogen. See, chlorine reacts with hydrogen, very simple, combines to form 2HCl, hydrogen chloride. Not only like that, even it reacts with the elements of the hydrogen and forms respective compounds. For example, H2S, chlorine reacts, it will reduce hydrogen sulfide minus 2 to 0 and forms 2HCl. Not only that, even C10H16 plus chlorine. C will convert this into carbon, okay, and then HCl. Okay, sorry, 16HCl. Therefore, generally you can just multiply here by 8Cl2, 10 carbon, 10C. That means this is called camphene. Okay, or you can also call it as in some books they are given terpentine. That means chlorine reacts with the hydrogen from respective halides. HCl. One from hydrogen sulfide will come to HCl and reduces, oxidizes hydrogen sulfide to elemental sulfur, LOPPP. Even here C10, 02, once again carbon, black carbon, and forms HCl. Like this will react with the hydrogen. Okay. Now coming to the next reaction with ammonia. These are also important. Reaction with ammonia will start. These are very, very important reactions. Reaction with ammonia. How chlorine reacts with ammonia? The students here with excess ammonia. Excess ammonia, chlorine reacts. See, I am telling you excess. Now this side excess ammonia will form ammonium chloride, NH4Cl, and remember. when it reacts with excess ammonia. But the same chlorine, the same ammonia reacts with excess chlorine. The reaction will form nitrogen trichloride, NCl3 and HCl. Simple. 3Cl2, 3HCl. About a hit and drag method, 4NH3. Okay. So generally, now nitrogen becomes imbalance here. 2NH4 cell if you multiply. What about chlorine? Already balance. But hydrogen is imbalance. To make it, you have to multiply here by 8. Okay. So here 6NH4 cell, because 8 3 are 24. Here are 6 4 are 24. 6 nitrogen, 2 nitrogen here. Now it's a balance. Okay. Sorry, here 3Cl. Chlorine 6, therefore 3Cl. 3Cl2 plus 8NH3 giving 6NH4Cl plus. It is the balance equation for X. That means when chlorine reacts with excess ammonia, liquor ammonia, it will form ammonium chloride and nitrogen. Okay. From -3 to 2, that is generally here it is +3 and 0. That means it gets oxidized and less reduced. Oxidized to ammonium chloride, reduced to nitrogen. Got it? Okay. Sorry, both the products it is oxidized will be 0. From -3 to 2 here +3 and here. Okay, now ammonia means this is the explosive compound. Highly unstable explosive compound. Nitrogen trichloride. That means if they ask you with excess ammonia it will form ammonium chloride and nitrogen. With excess chlorine, ammonia forms an important explosive nitrogen trichloride along with HCl, which is very important for CET and theory also. Theory compulsory question. Okay. For theory, very important. Anyone can be asked for 2 marks. This is reactivity with the ammonia. That's it. Now, coming to the next very important thing. Coming to the next reaction with alkalis. Reaction with the alkalis. Chlorine reacts with sodium hydroxide, cold dilute, sodium hydroxide, natural limited amount. So it will undergo this proportionation reaction to form sodium chloride NaCl, sodium hypochlorite NaCl, and H2O. That is water. Okay, so just multiply by 2, right, and everything is balanced. This is sodium hypochlorite. Sodium hypochlorite. Okay, -1. Here +1. Here 0. Same element C. Undergoes oxidation and reduction. It's a disproportionation reaction. Right? Okay. Now the same chlorine atom, when reacts with strong base sodium hydroxide, that is hot and concentrated. It forms sodium chloride, sodium chlorate and water. Okay. 6 NaOH, 5 NaCl, NaCl3 and H2O. So since 5 plus 1, so it is 3Cl. So this is sodium chlorate. This sodium. Here also -1 plus 1. Same element undergoes oxidation and plus reduction. Very important as per need and theory concerns. Both the theory and the weak one. That means with the strong alkali chlorine depends upon the medium. If it is cold and dilute, you will get the sodium chloride, sodium hypochlorite. If it is hot and excess concentrated at caustic soda, then you will get sodium chloride and sodium chlorate. Okay, very, very important. Right, now coming to lastly, what about the reaction with the weak that is alkali. We take calcium hydroxide, that is regular Cl2 with calcium hydroxide. Slave line. Okay, now you get very important compound CaOCl2, calcium oxychloride. Okay, and this is called bleaching powder. Along with calcium chloride and the 2Cl2, 2CaCl2, H2O. Okay, calcium chloride along with the water. But calcium oxychloride, CaCl2, okay, and even CaOH taken twice, dot 2H2. This is composition of bleaching powder. But actually, short form of the chemical name is calcium oxychloride is bleaching powder. But when they ask you composition of bleaching powder, this CaOCl2, CaCl2, CaOH taken twice, dot 2H2O. This is about what we call it as, that is bleaching powder. Right? This is also very, very important for need and theory purpose. That means they will react with the strong alkali, undergo disproportionation depending upon condition. And here also weak alkali forms very important compound, bleaching powder, calcium oxychloride. Okay? Right. Not only this, even another properties of this chlorine undergoes even reaction with the hydrocarbons. And more reactions with the hydrocarbons. So chlorine reacts with methane, undergoes substitution reaction in the presence of diffuse sunlight and form methyl chloride, right? Then methylene chloride, okay, even chloroform, or even CCl4. It will undergo in the first year studied by the method of what? Free radical mechanism. It undergoes until all the hydrogen atoms are replaced by chlorine. It will form monosubstituted, disubstituted, trisubstituted, even tetrasubstituted. Methyl chloride, methylene chloride, chloroform, carbon tetrachloride. Monochloromethane, dichloromethane, trichloromethane, tetrachloromethane. Trichloromethane itself is called chloroform. Okay? Even see, hydrocarbon like C2H4 undergoes addition reaction and forms a C2H4Cl. You write this structurally like this. Plus Cl. Reacts across double bond, breaks it to form Cl and 1,2 dichloroethane. And this is it. Like this, it reacts with hydrocarbons, methyl alkanes it undergoes substitution. With alkenes and alkynes it undergoes addition reaction across the double bond and form respective substituted products. Okay. Right. Now last oxidizing property. Some oxidizing property and lastly bleaching action. Bleaching action of the fluid because we have to complete it today, right? Okay. Now coming to oxidizing property. Oxidizing property of fluid. See, it oxidizes ferrous sulfate. Okay, sodium sulfide. Not only sodium sulfide, even it also sulfur dioxide. Okay, we have iron. Ferrous sulfate in the presence of acidic medium, it gets oxidized to ferric sulfate, Fe2SO4 taken thrice, and itself will be reduced to HCl. Okay. So generally 2FeSO4 plus 3H2SO4 and 2HCl. Right, 2HCl. No, 3 2s are 6 plus 2. HCl, therefore 3Cl3. Like the same, ferrous sulfate plus 2 plus 3. It oxidizes, and even see chlorine from 0 to minus. But this is possible in acidic medium. Okay? But this is possible in acidic medium. Like this, just we can make it out. Sorry, this equation, first one is not balanced. Ferrous sulfate is oxidized to ferric sulfate, right? 2FeSO4, which is not necessary because 3 sulfates are already here. Not necessary, this is also not necessary, just 2HCl. And then, sorry, ferrous sulfate to ferric sulfate. So now it's a balance. 2 sulfate here, 1 sulfate already. 2 fluorine. 2 ferrous sulfate balance, chlorine and hydrogen automatically balance. Okay, this is in acidic medium. But sodium sulfide in neutral medium, Cl2, it will get oxidized to sodium sulfate and Na2SO4 and reduced product is HCl. Here also sodium sulfide is there, water, okay. Now chlorine to HCl. Okay, HCl is also just 2HCl. Everything is balanced. Okay. Now sulfur dioxide also in acidic medium. Here plus 3 2 plus 4 0 2 minus 1. Right? Plus 3 2 plus 4 oxidized. And sulfur dioxide also to sulfuric acid H2SO and HCl. Here also same thing, 2HCl. H2SO4. H2SO4. Right? So plus 4 2 plus 6 0 2 minus 1. Lastly iodine 2. Iodine also is the presence of water. Chlorine in 0 oxidation state, iodine 2 HiO3, hydroiodic acid and HCl. Right? 2 HiO3. 6. So 6H2O. Sorry, 2 are already there. 4 HCl if I make it. 2 3 6 definitely. 6H2O. Okay. Chlorine. Sorry, this should be 10 HCl because we already right? Now it's a balance. For here also iodine 0 to hydroiodic acid plus 5 and chlorine to minus 1. Like this, these are the oxidizing property of chlorine. That means chlorine oxidizes ferrous sulfate to ferric sulfate, sodium sulfide to sodium sulfide, sulfur dioxide to sulfuric acid, and iodine to hydroiodic acid. In all cases, itself will reduce to HCl. Itself to HCl. Now, chlorine is not only known for its oxidizing property, even for its bleaching property. It's known for its bleaching action. See, it's powerful bleaching and it's having permanent bleaching due to what? Due to oxidation. In the presence of water. That means it will react with water to form. Right? That is HCl, O and HCl first. And this HCl, O, hypochlorous acid, dissociate to form. Okay, HCl and nascent oxygen. And this nascent oxygen, right, is responsible for bleaching property. It bleaches not only paper, pulp, even ivory, in textiles, even for silk also, even for cotton materials, it is used for bleaching action. And its bleaching action is permanent due to oxidation. But in sulfur, I told you, bleaching action is due to reducing nature. It is not permanent, but this is permanent due to its what? Moisture, due to presence of moisture. Very important for safety, right? So this is the organ. It bleaches ivory, many textiles, but it is permanent. That means colored substance, if you take and bleach, that bleaches, it changes the color due to what? Its nascent nature. That is called bleaching action. That's it. So now lastly, what are the uses of chlorine? Chlorine is by Deacon's process. Chlorine is used as bleaching now only. For bleaching purpose, it is used to bleach ivory, okay, and even organic matter, and makes the colored substance into colorless due to bleaching action. Even for its permanent bleaching action, it is used for bleaching powder, in the form of bleaching powder, we are used for cleaning purpose, right? And it is used to prepare important sodium chloride, sodium chloride, sodium chlorate compounds, important that is salts, right? And main importantly, this chlorine is used to prepare tear gas, very important for CED purpose. It is used to prepare tear gas. In organic chemistry, we come to know this is CCl3 and O2. Okay? 1,1,1 trichloronitrate. This is tear gas. Chlorine nitrate actually is called. Chlorine nitrate. Trichloronitrate. Right? That's only 1,1,1 trichloronitrate. Tear gas. And even mustard gas. Okay, which is used for warfare, especially mustard gas. And it is sulfur, CS2, CS2, Cl, CS2, CS2, Cl. Okay, this is called mustard gas. It is used for warfare, especially by the army. Right? If they produce any poisonous gas, definitely that will be. This is only the mustard gas, poisonous gas used in the guerrilla warfare. Right? Okay, so that's about very important application of the chlorine I. Apart from this, chlorine is having many applications for sterilizing drinking water, okay, and extraction of gold and platinum. Extraction of gold and platinum in the form of what we call it as what is that is called aquaresia mixture in extraction of gold and platinum. Right? So these are the very important uses that you can read it out from NCERT textbooks. This completes chlorine. The chlorine properties are known, so don't get confused. Right? So what are those? First, reaction metals in order. Mainly reaction with strong alkali, sodium hydroxide, dilute concentrated medium. Okay? Then calcium hydroxide, gypsum. Definite question. Please make 100% 2 marks even for NEET as well as theory. Okay? Right. Then you can come for oxidizing property, not so important, and this. And one, even for theory preparation, lab method or defense process, definitely one question. So today we'll stop here, students. Enjoy the day and have a nice day. Thank you from PANCHNATH. So tomorrow I will just complete HCl, okay, then interhalogen compounds. If time permits, we'll complete even oxide acids or remaining, that's chlorine. Right? Thank you.